And it's recording. Yeah. Welcome on our DataOps Poland, and today our guest is Peter, and presentation is about Apache Druid. Peter, stage is yours, and you are the star.
Thank you. Is that sharing okay? That's the first question.
Yeah, I see them.
Good, cool. Okay. Well, thank you for inviting me, Thomas and Philip. I come from a company called Imply. If you don't know who Imply are, Imply was founded by some of the original project members of Apache Druid. This is me, the good-looking one. So my name is Peter Marshall. I've got 20 years experience in enterprise architecture from CRM, EDRM, BI, and master data management for anybody who likes master data management. I've got a BA in theology and computer studies, but we're not here to talk about God today. So if you've got any questions about God, you'll have to come to England and buy me a beer first, and then we can argue about God. I am a bit of a book collector, which means I buy books and then don't read them. I don't know if there's anybody else who's like that, but I'm definitely like that. And I buy AV equipment that's too expensive. And for those of you who know, I believe that the prime timeline in Star Trek is the only real timeline, and I'm glad to say I'm not in poor company there. If anybody wants to contact me, my email address is at the bottom there. If I have any questions or anything you want to talk to me about, do send me an email, peter.marshall@imply.io. And there's also my website address there, petermarshall.io, which has got my Twitter feed and everything on it. So please connect with me afterwards. I will have QR codes through this presentation. So it's there to kind of signpost you to other information if you want to go and have a look. So feel free to scan the codes. I wonder how many of you are downloading an app. Just scan that code and it'll take you to some other information about what I'm saying. Okay, so I've actually got two different talks I'm going to give you today. The first one is just about where Druid came from and why Druid exists in the first place. And then I have a second set of slides where I'm going to go into the real technicalities of it. So I'm going to do this slide deck first, then break for a bit, and then let you ask any questions. If you want to challenge me on anything, then please do. And then I'll go into the actual technicalities of it. And we'll look at what's inside a Druid cluster and what the moving parts are. We've got about an hour and a half, 2 hours, is that right, altogether?
Yeah, but let's try to do like 1 hour and 1.5 hours, okay?
Okay, cool, yeah. Let people go and eat pizza and drink beer. I'm with you. Okay, so I'm going to go through why I believe real-time analytics exists in the first place. Then we'll have a look at what kind of applications people build on top of Druid. So we'll start to think about what the characteristics of those applications are, the kind of user needs that get met when you build an application on top of Druid, and then I'll go through some examples that are out there in the wild. So believe it or not, that's me. Nobody's allowed to laugh. That was a very long time ago. And as you could probably tell from my other picture, I am quite old now. I've been around for quite a long time. And in that time, there's always two things that seem to change in IT. It's either going to be someone has invented something new, or some new person has been hired, or I've got a new director and they're asking for something insane. Those are the two things. And that tension between those two things is never going to go away. As the technology has changed, the people that we're working for are asking for more things. And then as our customers change, it might go into a different country, a different market, a different app. We have to change the technology as well. So I'm going to start by just looking at the technology first, because that kind of hints at why Apache Druid emerged as a new technology in the first place. When I started working in IT in a long time ago, 1998, I had an Oracle 6 database, and the only way really to get anything out of that was to write things in SQL, or PLSQL to be technically correct. And it was weird that was the first time I think I'd come across a programming language that had been standardized to query databases. Like, it was weird that at that time that didn't exist. But you can only really use it for doing things like exporting data or doing mail merges or doing regular reports. And then Oracle came along and they said, well, hey, do you know what? Why don't you draw your entity relationship diagram using Oracle Business Objects? And everyone went, yes, that's a brilliant idea. I'm definitely going to do that. So then I unfortunately became really passionate about really, really cool entity relationship diagrams that looked really, really complicated. And I'm quite proud of my entity relationship diagrams. But anyway, the problem is that that's really, really slow. But at that time, like in late 90s, early 2000s, places where I was working didn't really care. They didn't need it to be fast because there was only a few people doing a very few number of things. Which was great when I wanted to print out everybody's bank statement for the last month. I just ran the SQL and printed out a load of statements, but it wasn't really very good when someone started to ask me questions about that data and I couldn't answer it. So I was rescued by some guy called Edgar Codd who said, that's ridiculous, stop doing that. So he introduced the first way to do actual meaningful analytics on the data. And he started this movement to take data from databases, to do a bit of curation through ETL, and then to do calculations ahead of time. So we know those as data cubes, but I'm still surprised that aged 18, I didn't have one. And like the difference is quite remarkable. And we forget about that sometimes. So not only do the reports I was writing run much faster, but I could also slice and dice the data based on, say, a customer segment, or I could drill down into it, like from continent down to city. And I could do really complicated statistical calculations, and they're all available online. And that's where we get OLAP from, which is awesome until these guys appeared and the internet happened, because then we had huge volumes of data from websites and from mobile apps, because the nature of the companies we work for changed. People went from physical shops replaced with online ones, and local shops got replaced with these huge international online e-commerce websites. And ETL has really begun to creak for two reasons. First of all, that ETL just takes time. And the bigger the database is, the longer the ETL takes to run. That's our classic volume and velocity problems. But also, ETL costs money to make faster. You need more cores, more memory, more disk space. And in like the world I was in with Microsoft SQL Server, that costs you a ton of money to do. And the second one is because ETL takes a design effort, and you can only take advantage of a data cube if it's been built to answer the question that you wanted it to answer. When you've got something new, or heaven forbid, the worst thing in the world happens and someone says, well, actually, we're going to change from Oracle now to Ingress, and you spend 6 months having a nervous breakdown, that you have to go and reprogram all this ETL, and it's just a nightmare. So then we had Google and Yahoo and LinkedIn and all our other big friends out there in San Francisco, and they turned the question of data on its head. Thank goodness. They said, if I've got this kind of data, like structured or unstructured or semi-structured data, and I've got this kind of thing like websites or purchases on a website or networks, and I've got these specific kind of questions, like I want to search it, or I want to do statistics, or I want to understand the relationships, then they said, what should the database be? And so they ended up giving us these wonderful databases, columnar databases, which are splitting all of our data up and doing the data distribution and allowing you to answer questions in parallel and get answers almost instantly about one column of data. We had log search systems, so anything where we want to ingest data at a very high rate and then filter and search that data, like journeys on websites or telecoms traffic or stock market transactions or application error logs or people sending each other emails that they shouldn't be sending one another. This is great for that, log search systems. And then we had time series databases, which have like helped us move that further and still have this great ingestion capability, but now we can ask very specific questions that are about periods of time, like what's my daily number of customers and how does that compare to what it was like last week? And then of course we've got document databases, and I'm a bit of a fanboy for graph databases. I don't know why, that help us understand the relationships between things. which is fantastic, except we've all ended up with Macaulay Culkin, who is great at doing one particular specific thing and not very good at anything else. But analytics is a universal technical problem. Columnar databases aren't designed from the ground up to ingest very, very large volumes of real-time data, and they're not always very good at searching for stuff. Log search systems are not brilliant for statistical calculations, and they're not so good at data with high dimensionality, with lots of columns, or with high cardinality, i.e. lots of different values. And time series databases are fantastic for doing windowed aggregations and comparisons, but they're not brilliant when I want to ask questions about different statistics to the one that I've set them up to do, like if I wanted to break something down by customer segment. So that's great. I've talked about the technology bit, but we've got to remember that we work with human beings, unfortunately, from time to time. And I met this particular human being in about 2005. His name is Carlos. He has a fantastic beard, not unlike my own, which is also amazing. And Carlos is peculiar, and he's very peculiar to people of my age because he's not like someone that I worked with in 1998 when I started in IT. And lots of companies in the UK and in other areas of Europe, I know probably haven't met this person either. So this sometimes is a bit alien, but there's 4 things that make Carlos a bit weird. First of all, his entire world when he gets up in the morning to when he goes to bed is powered by data at an extremely large scale. And he has hundreds of applications on his phone on lots of different devices around the house. And each one of those devices and each one of those apps is for something completely different. He's a very different person to me when I was growing up. Secondly, he's a very agile person. So he's a very demanding person. He will decide he wants to stop using your app and start to use someone else's just because he doesn't like it anymore, whenever he feels like it. And thirdly, he's very aware. So he knows that data is monetizable. We can't hide that from anybody anymore. And he feels like he has a legal right to access the data with things like GDPR and the sister in California as well. He's not the kind of person who's going to want to write a report specification to get to his data. He wants to see it immediately, and he wants to explore it, and he wants to play with it because he feels like he has the right to do that. And then finally, he's a very mindful person. Now, I don't mean that he spends lots of time meditating and hovering above his desk eating donuts. I don't mean that. I mean, like, he's a person who is going to use both sides of his brain at the same time. He wants to use instincts and the skills that he has to make decisions, but he also wants to be grounded in the knowledge of what his team knows and what he knows of the past. And then he wants to socialize that and have a discussion with other people around him. So there's 4 things, like, that's all wicked, great, fantastic, nice to meet you, Carlos. But it presents us in IT with a big problem, because in a digital world, we've got volume, velocity, and variety is an issue. We've got huge numbers of rows, very broad data sets, lots of different data domains, and many more transactions per second than what I thought was imaginable. And any database system that can't handle very wide and very long data, especially if it's fast arriving, is going to become a problem. When it comes to him being agile, we have to, in IT, now be persistent innovators. I remember a time when the thing that I spent my time doing every day was doing Gantt charts. And I used to love Gantt charts. Oh, I love Gantt charts. I still quite love Gantt charts. But nowadays we don't do that. Now we have rapid development methodologies, and we have schemas that change. We have to adapt to survive as people in IT and people in business. So any database system that is fixed in the way that it defines the schema, or is fixed in the way that it defines what the statistics are we can get out, are going to start looking like a pain in the backside. When it comes to him being aware, any database system that in any way hinders you and me from delivering an application to him that gives him what he wants when he wants it is very slowly going to look like the stumbling block. And it's going to be us that get it in the neck for doing that. And then finally, this mindful thing is really important, because if we don't have a database system that can enable us to have both the real time, i.e. event-based data that's arriving now, alongside the historical data, it means that he's going to make time-sensitive decisions rashly. He's going to make them as a snap decision based on only the recent information that he's got in front of him, instead of using all of the old data and all the stuff that he knows in order to make a good decision. So, and any database that can't scale so that he can share his findings with other people so that they can all have a conversation is going to discourage anyone in the business from socializing that decision making, and the decision makings are going to be slow, and the user interface is, well, it's going to be quite boring, to be fair. So here we get to Druid. This is the stuff I love. So Druid is trying to solve that problem by bringing these three different technologies together. First of all, it's going to bring together the stuff that you'd associate with a log search system. So it brings together the ingestion, the flexible schema, and the text search capabilities of search platforms. The second thing is that it's highly optimized for event-based data, and it has time-based functions and low latency ingestion, just as you'd find in a time series database. And then thirdly, it brings in the efficient storage, the super fast statistical queries, the distribution of data, that we'd find in a columnarized database. So what we end up with is a high performance real-time analytics database. That's exactly how a Druid is defined. What do I mean? It means that it's a very mature, very scalable ingestion capability. So many millions of events per second if you need to. It's got this distributed query engine inside it that scales so that hundreds of different users can answer all sorts of statistical questions and get the responses back at sub-second speed. And all of that activity is not fixed by a data cube. It's all ad hoc exploration. And then finally, we have this really optimized, very refined storage system. So it's so optimized that you get people who are holding many, many years of historical data alongside the event-based data in the same system. So it doesn't cost them a fortune. So in many cases, what that means is that people can swap out certain NoSQL databases, like a time series database, for example, to give them more statistical flexibility. Or maybe they'll use Druid alongside their log search systems so that they're speeding up the analytics on top of that data. Or they might get statistics on fast arriving time series data in a way that they can't do it in their existing columnar databases. So that's kind of the environment that led to Druid being created and why it's brought these three technologies together. So what are the kind of characteristics of a Druid powered application? What kind of needs do those applications meet for people? So this is my top 7. It's a weird number, I know, but this is my top 7 different areas that Druid can help in. So maybe it will be used to make more data accessible to more people. It might be that you would provide them with broader, deeper, longer data sets for them to do analysis on. You might use it for very large, fast increasing, changeable data sources. You might use it to give them access to the most recent data, to provoke them to be curious and ask why. And more, you might then give them the opportunity to actually go and find out why through some user interface. You might let them go and look at just historical data so that they can use that to tell the whole story of why something is happening and to explore that in an ad hoc way. In IT, what you might do if you're building, especially for like very fast moving applications and web interfaces and mobile devices, you might use Druid so that you're shrinking the overall engineering effort of producing that, because you're not having to do ETL jobs, because you're not having to define cubes, you're not having to do pre-processing. You can just pick that up straight away. And ultimately, all of these things, really, all of these are about making data available faster to end users and reducing the latency. So all of the examples that we see in a minute hit on some of these points, why Netflix and why Yahoo, people like that have pulled onto Druid and embedded it in their data pipeline. So what kind of application? So let's imagine we might have an application that gives people the complete picture of all the data. Secondly, we might make it the freshest, most frequently updated, fast arriving data that we have available. And we might have an interface on the top that allows Carlos to have a real conversation with the data. So it won't have a save button, it won't have an apply button. He'll be able to slice and dice and play around with the data in any way that he pleases. And to that point, we will have this kind of ad hoc, very fun interface that we've built on the top of it, and it'd be very responsive. So I don't mean that when you hold it sideways, your mobile phone will adjust appropriately. I don't mean that. I mean that it's a very fluid, very quick to draw, no progress bars kind of interface. So to do that, to build that kind of application, these are some conditions that we'd put on the data. So the data probably will want to arrive in real time. It might not have to, like we could do very small batches, but in most situations it's going to be real time, but it will always be event-based, by which I mean it'll be event stamped. So it fits into event-based pipelines really well. And while the data is likely to be voluminous, by which I mean big, it's probably always going to be the most valuable data. Why? Because people need that kind of information. We've got to stop in IT holding on to the stuff that's most valuable just in case someone doesn't like what they see. Remember, we also have to try and help people explore this data. So in IT, we have to think like statisticians. That means we have to prepare the data well. We'll probably need to think about cleaning it. We might have to enrich it. To a certain degree, we might have to join it. And when it gets into Druid, it will need to be normalized as much as we possibly can. And also we'll need to retain many different dimensions so that people can group by different things when they feel like it. So we won't strip them all out just because our ETL process or our cube or our ELT process can't cope with it. We'll leave them in. And it doesn't matter anymore whether it's high cardinality data. In fact, we probably treat that in a special way so that it still remains performant. And we won't prescribe the functions that Carlos can perform either ahead of time. We won't decide, well, you can only have the max of something. Instead, we'll provide them with lots and lots of different measures and different measure points so that we can let them decide what statistics they want. And all of this is to help him be curious, to help him to reflect on things well, and to help him talk to other people and to the data to make the best possible decision that he can. So this is all the kind of data that flows into Druid. If you're thinking about using Druid, you want to research Druid, it's probably a good idea to go through these and just think, okay, am I ticking many of these? Am I only looking at one of them? And how can I expand that? And how can I help my company and my business or the organization I work with understand that we don't have to be as constrained as we used to be? Well, that's great, but what do we put on the top of it? Okay, so maybe I will put Superset or Metabase or Tableau or Looker on top of it. And that's like the traditional BI type work tools that everyone's familiar with. In fact, there's a general JDBC connector for Druid. Anything that can do SQL over JDBC can connect to it. Or maybe I'll use Grafana because we love Grafana. Oh, Grafana. So we can put Druid behind Grafana as a native connector for that. And we can have all these wonderful dashboards on our big screens on the wall. Wonderful. And because I work for Imply, maybe you'll use something like Imply Pivot, which is a slice and dice real-time exploration tool. maybe what I'll do is that I will build something really unique. And on this really unique interface, it'll have very high throughput of queries and very low latency to the data. It will be highly bespoke. It will be a unique interface that's very fun, very complete, that I can adapt really quickly when I want to change something. And I will help my business differentiate itself in the marketplace. Or maybe I've already got something, I've already written something, and what I'm actually doing is modernizing it, and I'm having problems with that end user interface getting the statistics quickly enough to people. Well, okay, I'll plug it into Druid instead, and I'll get that user interface to be more fluid, a lot friendlier, and a lot quicker in getting its results to people. Well, maybe I spend a lot of time with data scientists who always make me feel very nervous because they always have a lot more qualifications than I do. In fact, a lot more qualifications than anybody that I know. But what we might do is we might give them Druid access to some of their data, might accelerate the kind of data they're looking at in their data lake so that they don't have to wait 3 days anymore for some kind of statistics that they're doing a quick exploration of the data on. We'll just give them immediate access. And we won't just be to the older data that will give them faster access, but we'll also give them access to the latest data as well to help them iterate through their models. Or maybe we'll in some way plug their model into Apache Druid itself and let it use that data in Apache Druid to drive other activity. So this is a result of a survey from June 2019. You can go and have a look at it. It's on the Imply blog, or go and click on that, scan that little code. Just gives you an idea of what people were doing with Apache Druid last year. One of the biggest areas of adoption for Druid is in IoT, and that's possibly because people are switching from the time series databases when they can't get the flexibility around the statistics that they need quickly enough. So I see a lot of people doing that. And digital advertising, there is a reason why that's massive that I'll come to in a minute, but IoT is definite growth for Apache Druid. So who's using Druid? People who are using Druid have got these 4 qualities. They're digital organizations, lots of digital data. They're all trying to democratize the analytical experience so lots of people can play with the data. And they're all working with people who are like Carlos, who are very mindful and who wants to see the real time and the historical data together and socialize that. And they're working with people who are in often very competitive environments where their end product has to adapt very quickly to keep competitive. So not all the businesses have all 4 of these things, but they will have at least 2 of them, in my opinion. So, okay. Let's get to the interesting stuff now. I should stop boring everybody and get on to the interesting stuff of some actual real world examples. And all of these you'll find on the Powered by Druid website. So if you go to druid.io and just click on Powered by, you get a whole list of them. If there's any that you see on what I'm about to talk about, go and Google each one and just stick Apache Druid next to the search term and you'll get a whole load of content about what people are doing with this. And as I say, scan those QR codes and you'll see more detail about each of the use cases that I'll go through. And tomorrow, yes, it is tomorrow. I'm just checking. It is tomorrow. I'm presenting the Virtual Druid Summit, which is being broadcast out of San Francisco tomorrow. Go and register for it. There's some really cool companies talking. We've got Twitch, we've got Twitter, I think, Netflix, I can't remember the others, but go and have a look and hear about what other people are doing with Druid. Okay, so the Powered by page, I'm going to group these together into 3 different buckets. So the first bucket is telemetry, then we'll look at anybody who's doing stuff with data about people, and then people who are using Druid for stuff to do with marketing. So here's some good telemetry use cases. So telemetry, my definition, is anything that tells us about what machines are doing, whether that's an application or whether it's hardware. So eBay, for example, used Druid to monitor their entire application infrastructure. And another company that uses Druid is Netflix. So Netflix have got dashboards and lots of different visuals about the quality of experience that you and I have when we're using their applications. as well as whether we're paying our bills. And they are ingesting about 130 billion events every day. So in 2018, so it's a couple of years ago now, they said that they had 160 billion client-side events being collected for all 135 million members across the world, from TV, web, iOS, Android, all the different apps that they provision. But the end user for this data is site reliability engineering and DevOps. They wanted to know questions like, how long did the app take to launch? How long did it take between someone pressing the play button and it actually starting to play the video? How long did it take for the details page to load? So to give those people the ability to answer that question, they had 29 different dimensions inside Druid. It's got geographic data, tells them about the network types that we're using, a little bit of information about our devices, and they're pushing the data into Druid from Kafka. There's a Spark job that enriches that data stream as it goes into Druid. And it enables them to have a Tableau sat on the top and helps people do that curiosity thing, to do that investigation thing, so that they can have a conversation with the data very, very quickly, both real-time and historical data. So they've got visuals and dashboards on top of that. Their video is awesome, and yeah, it's cool. Go and listen to them tomorrow. Another example is NTT Communications. So these guys are consuming information from their telecommunications network. So NTT are the fourth largest telecoms company in the world, and they're using Druid on top of their network traffic. So doing flow analytics across their global internet backbone. So they're consuming about 100,000 events per second into their Druid cluster so that they could free themselves from the constraints and the cost of off-the-shelf network monitoring tools. It's not just because they wanted their own KPIs or their own dashboards, but because they wanted more people to have access to that data in order to ask questions. So they do capacity analysis, they do matrix analysis, they do peering analysis, and users create their own custom dashboards on top of that data and then share those dashboards throughout their different teams. So they've now got this solid foundation in Druid for network flow analysis. They've got a single environment for all of their infrastructure and topology data, their forward plane data, their control plane data. And they're planning to expand that to include more pieces of data like round trip time, jitter, packet loss, quality of network paths, so that they can improve and harden the infrastructure. That's a great story of how a tool like Druid, I'd like to say because of Druid, but because of Druid, they're enabling more people to get involved in the discussion about data, and not to do that in a restrictive way, but to enable people to talk to it and ask why in a very fluid way. So, okay, let's start to talk about people who are using it for people data, so behavioral information about what people are doing. So that could be clickstream data from e-commerce sites, it could be web portals, it could be mobile apps and games. Lyft is a good example. So Lyft is an Uber competitor in North America. They are using Druid to power visualizations of their rider data and also to feed into their data science teams. And then we have Airbnb, who are doing dashboards for real-time tracking and monitoring of different aspects of their business and of their computer systems. They're doing it where the timeliness of the dashboards is critical to the daily operation of what's going on. In other words, they need to know very, very quickly, but they need to make decisions in a very informed way and in a freeing way. Walmart are also using Druid. There's a fantastic video from the Druid Virtual Summit. SK Telecom, another telecoms communication network based in South Korea. They actually have a tool that they've built on top of Druid called Metatron Discovery, with things like cohort analysis, geospatial analysis, and again, very large amounts of data. The Central Bank of Turkey is really interesting. So in the Central Bank of Turkey, they were using a classic pipeline like we were talking about earlier. They had Kafka being pushed into NiFi, and then statistics being generated then and put into MongoDB. They were using Apache Zeppelin on top with Python, and then they had Power BI sat on top of that workflow as well. ultimately, my interpretation of what they've said is that the end users just couldn't look at the whole picture, and they couldn't look at the whole picture in real time either. So they natively connected Druid to Kafka, which removed all the batch processing. And instead, they've put Superset on the top, which is the screenshots you can see here. Superset, the open source BI tool, natively connects to Druid. And then they use something called PySpark, which they're then sitting on top of Druid in order to do Spark analysis as well. Very good presentation. Do recommend going have a look at that one. Here's a personal favorite of mine. Love this company. They're very, very friendly, always talking about Druid. They are a European company they're a global company, I should say. And if any of you are game developers, they offer an SDK that you can plug into your game, and it will emit event data about how many coins people are spending and how difficult the levels are and things like that. So I can blame game analytics for me finding it impossible to play some games. It's all their fault. But anyway, what they tried to do was to build their own pipeline using tools available in Amazon. The short story is that as they started to develop the product and they started to make the product better and they got more popular with people, those statistics that they were computing, that pipeline, that processing began to really creak. They became really inflexible. And yeah, that's terrible for people looking at this data, but it's also terrible for product owners, because product owners were then limited in what they could do to this end user interface that you can see. So people couldn't filter things, they couldn't slice things, they couldn't produce the dashboards that they wanted to. So they've implemented Druid. Druid connects natively to Amazon Kinesis. And in fact, they've built an Erlang, they've contributed an Erlang library that sits on top of Druid, for any of you who like Erlang. And then this app that you can see here is built in Angular and connects directly through those APIs into Druid. So there is a mystery company, and I'm not going to go into these because they're speaking at the Virtual Druid Summit tomorrow. There is a company who, shall we say, they help people stream themselves playing computer games onto the internet. And they had real problems with A/B testing. They couldn't work out whether fixes they were applying were actually having the effect that they wanted them to have. They couldn't understand their engagement data. So they have done a very similar thing to game analytics. They just pull that directly into Amazon Kinesis, out of Kinesis into Druid, and then they have a UI on top of that where people can do the real-time analytics, where they've got dashboards, and they're also providing that data for next-gen apps. Very quickly, I'm going to finish with the marketing one. So this is where Druid was born. So it's no surprise that this is the largest area of adoption for Druid. So it's advertising exchanges, it's demand side platforms, it's campaign management, lots of big names on there. This is Twitter MoPub. So if you ever work with a company that is putting adverts through Twitter, they are going to use this tool. This is a great example of the kind of tool you can build on top of Druid. So I have a very creative space where I can drag and drop dimensions. I can set filter criteria. I can compare periods of time. I can set up my own measures, my own calculated values, and I can decide on whatever visual I like at any particular point of time. I'm not hindered in any way by pre-computation or by the compilation of a cube. And at Twitter, they deployed Druid extremely quickly. It integrated it into a pipeline that includes Hadoop, actually. And they released this MoPub Analytics as the front end to quite a large Druid deployment. As you can imagine with Twitter, it's got many thousands of nodes. But the thing to note here is that this is a fun and cool thing to do. I wish I could do you a live demo, but you can just like pull things left, right, and center and like reorder stuff and change the colors and la la la. It's just really fun to do. So that stuff that like could be quite boring with data becomes an interface that's really conversational, where I can do ad hoc stuff really, really quickly. And then there's a group of people who are doing anomaly detection, and they're building analytics platforms. My personal favorite right now is TimeFlow. They've got lots of Medium blog posts that they're doing. They're talking about how they're using Druid for a whole range of different things, including anomaly detection using, I believe it's Yahoo Sherlock, which is a plugin you can sit on top of Druid. So there you go. Where did it come from? It came from a natural shift in IT from how the technology is developing, and also, I'd say more so, with the people that we're dealing with now. The kind of characteristics, well, they're complete, they're statistical, It's very distinctive, and it's across different companies, across different data domains. What kind of needs are they meeting? Well, they're meeting needs for a business to be more agile, for people to be more mindful when they're making decisions. It's to help us build those digital services and products quicker. And it's also to satisfy this right of access that people feel that they have nowadays. And the kind of examples we've got, well, all of those that you've seen are about democratizing data. They're all about making ad hoc analysis. And quite often it's on the most recent data, and it's all done at speed. Okay, cool. That's my first one done. So any set of questions about those?
Yeah, you can use the raise a hand button.
Oh, hang on.
I mean, not you, the attenders.
Oh, so yeah, sorry. Sorry. That was the bit of the non-technical bit. So I actually talk about the things we're all interested in now, but it's just very cool what people are doing with it. I get very excited when I talk about Druid. There's so many things that people are doing. So, okay, right. The technical bit. Here we go. Is my screen sharing all right?
Yes, we see it.
Good, good. Okay, right. This is where I'm going to get lots of questions. Okay, so we're now going to have a look at exactly what's inside a Druid cluster. I'm going to keep an eye on the chat here, so please just ask me questions as we go through. Okay. Why did Druid end up being made? I'll tell you in detail now. Then I'll talk through what the main components of a cluster are. It can sound unwieldy to start with, but I reassure you it's not so bad, honestly. I'll then talk about the different optimizations that Druid performs on the underlying data that makes it so good for doing on-demand statistics, and then I will answer your Q&A, but I might go through as we go through. So let's look at actually why Druid got made. It was actually made in a company called METAMARKETS. It was open sourced out of there. And METAMARKETS is an advertising exchange. So the way these things work is that you have publishers who are offering up the advertising space, and it's very, very competitive. Advertisers have to bid on that space for the right person in order to get their advertising shown. So the company that offers this service has to be very clever, and it has to present evidence that it is right, it is putting the right adverts in front of the right people, and it's extremely complex. If anybody works with these advertising advertising exchanges, you'll know what I mean. So how did they present this evidence? Well, the problem was that they became very successful very quickly, and they couldn't deliver the insight into what their services were actually doing because the pipeline became unscalable. They had very poor query and ingestion scalability, and the data was very disjointed. So their event data and their batch data was separated. And the pipeline itself was limiting the product, very much like game analytics, as when they wanted to change something, it became very expensive, and mainly because of these pre-calculation jobs, but also dragging stuff out of data lakes and things. And all of that stuff that was happening in the middle meant that there was a very long latency between when the data was being produced and when it was actually being presented to people. So if you put yourself in the position of one of their end users, of one of their customers, it meant that you dimension to filter and sort and drill down on and understand why your adverts were or were not being placed correctly. All of the metrics were predetermined and fixed. So you had to live with whatever it was that the designer of this pipeline had come up with and thought that you might be interested in. And it had very limited context. So I couldn't understand the cause of something and the effect of something because of the size of the data that was available to me. So you have to live with this stale, out of date data. So they did what any of us would do, and they did a massive code and component review. If you would like to read it, it's written in a white paper available publicly. Just scan that code there, or just Google the Druid white paper. It's actually quite a cool read from about 2015. When you look at druid.io, you'll see that Druid, which is what they developed, is defined as a high-performance, real-time analytics database. And its core job is to give business users or software engineers or data scientists access to very fresh, fast arriving, complete data sets, no matter what the data domain is, and to do that on demand. So if you deploy Druid, you can just download the quick start. This is the main UI. I can set up and monitor all my ingestion jobs. I can shape the schema underneath that data. I can apply filters and I can apply transforms in real time on the data as it comes in. On the right-hand side there, you can see the monitoring. This has actually been improved this is an old screenshot, bad Peter Marshall. There's more functionality there now, but I can monitor what's happening in the cluster, and I can also execute a SQL query directly in there as well. This is Druid. It's nearly 8 years old now. So from being open sourced in 2012, it was incubating through 2018, 2019, and it's now graduated. It's now a top level project. And in fact, last week, we got 10,000 stars in GitHub and everyone was very excited. I haven't had my cake yet, but we're very excited. So please go and star us on GitHub because it's cool. Some highlights from the last few months, really, just to show how quickly Druid is developing and how much contribution there is from the community, as well as the data loader that you just saw being introduced in Druid 15. Druid 17 had an overhaul of the ingestion mechanism into something called super batch. So we have faster ingestion from more sources and in more formats. In Druid 18, the join term was added in SQL support. So now I can do master data lookup in real time. And in 0.19, vectorization was enabled by default. So I've now get much faster queries. So I've seen some people who've had a 15 times improvement in query speed by using vectorization. And I know that there's more of that to come. We've got more tuning to come. And we're also now looking at tuning the ingestion mechanism even further as well. So it's a very bright future for Druid. I'm here because I do believe Druid is very, very cool. I think it's the next generation of analytical query engine. And it's not built by a single company for just a few people somewhere in a remote part of the world. It's built by lots of people from all over the world, from Sydney to San Francisco, lots of contributors. There's more than 300 contributors regularly in the project. And I'm always saying, if you find a pull request and you fancy writing it, go and have a look at the pull requests and see if there's anything you can get involved with. So this is a quote from a guy called Tim Tully, who was Vice President of Engineering at Yahoo when he wrote this about Druid. He says it can do very large OLAP-style processing on the fly in hundreds of milliseconds instead of pre-calculating everything. The performance is great. Some of the tables we have internally in Druid have billions and billions of events in them, and we're scanning them in under a second, which is amazing, obviously. But there's three things I want to highlight. First of all, Druid is good for OLAP stuff. It's focused on statistics. Second thing is that it's doing this stuff on the fly. It's not pre-calculated. So I get much faster speed and responsiveness of products, but I also get to reduce the cost of the pipeline. And thirdly, he's talking about billions of events. Of course, he uses at Yahoo, but don't let that scare you. Although Druid is linearly scalable, it works for small data sets as well. So this is what they built at METAMARKETS, very similar to what we just saw, very ad hoc kind of querying, lots of slicing and dicing without having this dependency on the data cube being built in the background. So where does Druid fit in a pipeline? More technical, excellent. Please go and have a look at the blog post behind this. It's called The Big Data Zoo, written a few years ago, but it explains why Druid is seen as a query accelerator. So Druid in a pipeline typically fits after the data lake, after the message bus, and it does the analytics that powers those applications with sub-second statistical calculations. So I can connect Druid to my delivery mechanism. So I could connect it to Kafka, or I could connect it to Kinesis, or I might connect it to my storage system. So I might connect it to S3 or to Hadoop, for example, or PostgreSQL. So let's imagine that I'm going to use Devolte, the open source clickstream thing that you put into websites and it'll send you the information about the current session. I might use Devolte. I might send that directly into Kafka. And then just because I can, I might then do some Spark on that stream, push it back into Kafka again. And then Druid as a sink will just pull that data out of Kafka. And by doing that, I've completely skipped the storage layer. And that's one of the ways that you can build a pipeline with these extremely low latencies. And then we're going to push it into superset. And in the superset end of things, there is no cube that I've computed. I can build whatever I want to on top of superset without having that pre-computation. So yeah, go and have a look at that big data zoo for more examples about how it fits in. So what are the core components of a cluster? Well, Druid is simply a set of loosely coupled Java processes. So any Linux environment with the JRE can run these processes, whether that's a Docker container or whether it's a bare metal Linux server. So there are 3 families of processes. I've got query processes, which you'll be glad to know mean I can get data out of the cluster. The second is the data processes. These are to do with ingestion and storage of that data, and they give answers to those statistical questions. And then I have a series of processes that are called master processes that are to do with cluster coordination, tracking, and running tasks. These are the most boring ones, so let's get these out of the way. There are 2 processes here. One's called the coordinator, one's called the overlord. The coordinator has rules that say how the data is going to be balanced, how it's going to be distributed, how it's going to be replicated. And the overlord is looking after the general task management in the cluster. So this is the first dependency for a Druid cluster, is the metadata database. That's where it's recording all the movements of all the data within the cluster. So that could be Derby or MySQL or PostgreSQL. And the second dependency is for the overlord. So that relies currently still on Zookeeper, although kind of trying to move away from that. And that does all the process communications on all the leader elections. Now those 2 processes, although I said they're boring, they are actually the beating heart of a Druid cluster. So typically you want to have at least 3 servers in this role so that I can do things like, high availability, I can do things like rolling upgrades. So how do I get data in to Druid? So I can ingest data in batches, or I can do it with a direct connection to an event hub. So for batch ingestion, I've got lots of different options. I could use cloud, web, disk, Hadoop. I can take it from S3, from GCS, from Azure Blob, from HDFS, from HTTP, from local files. I can even ingest from another Druid cluster back into itself if I wanted to. And I can do it via SQL to MySQL and to Postgres. For events, the standard data sources are Kafka and Kinesis. And all of the data as it comes in is handled by the middle manager processes. That's where the ingestion tasks are actually run. If you do go and look at the docs, you'll see there's a new process called the indexer, which has got more efficient memory usage and more efficient resource usage in general, actually. Currently, most people I'm working with still using Middle Manager, but if you go and look at the Druid ASF Slack channel, you'll see lots of people have started to adopt the indexer as well, but they're doing similar jobs. And also, if you do start to look at Druid, make sure you know where the log files are when you're setting this up. They're very detailed and can be very helpful when you're troubleshooting, especially in a production environment, exactly what's going on. Now, I might combine both batch and event ingestion here. Why would I do that? I would do that so I can backfill my data. I could add late arriving data, or maybe I want to overwrite the data later. So it's good if you do start with event ingestion, also try and get a handle on the batch ingestion as well, just for future usage. Okay, data's coming in. Now I need somewhere to put it. So I'm going to put that into deep storage. This is the third dependency for a Druid cluster. So this could be S3, Google Cloud Storage, HDFS. There's your blob storage. There's a range of different ones. And once the data is coming in, the source data is coming in after a particular size of data has been reached or a certain period of time has elapsed, I'm going to write that into deep storage. It becomes version controlled. It becomes immutable at that point. And this process is the very cool process that turns this very good format for writing data into one that's good for analytics. And all of this hard work is being tracked by the master server, and there's lots of care taken around that workflow so we can do things like guarantee exactly once ingestion from Kafka. So now the middle manager process has started to write its data into the deep storage. Where does it go? Well, the master is instructing the cluster to replicate and distribute this data we've just processed and to make it available for statistical analysis on another process, which is called the historical process. and it gets an instruction to load that data from deep storage, and it now becomes responsible for answering questions about our historical data that's been optimized. And it does that according to balancing rules, and it's aware of the health and the size of the historical processes that we've got running. And this is one of the elastic infrastructure parts of Druid. When you have more data that you want to analyze, you add more historical processes. So generally, well, the default replication in Druid is 2. So really you want to have 2 historical processes, but 3 is better because you get better parallelization and balance. The largest cluster I know has 500 terabytes of data and many, many historical nodes for that parallelization. I can also tweak these rules, so I can say that there are dedicated groups of historical processes running, and we call those groups tiers. So I can target particular periods of time or particular data sets at those tiers. Why might I do that? I might do that if I've got some very old data, might even be 3 months old or later, sometimes years old, and I want to put those onto much cheaper boxes, and I don't have many cores on it, I don't have a lot of memory, I've got very slow disks on it. And that's how you do that using tiering rules. So that ability to scale linearly also applies to ingestion, and many of the input sources for Druid are parallelizable. So if I have large volumes of data or I've got faster arriving data, I add more middle manager processes. A good rule of thumb here is that Druid achieves 10 to 50,000 events per second per core. So I've seen a cluster with 3 million events per second on a cluster, and just by scaling out that process. So think of it this way. So the data is ingested and served by the middle managers, often in parallel. It's handed off to deep storage and responded to from the historical processes according to those rules. And again, that's done in parallel. Statistical questions are actually answered by the final process in a cluster. That's called the broker process. And this distributes the analysis tasks to the historicals or to the middle managers, and then it consolidates their answers and does any post-processing that's required. So I can do time scan, group by, top N. I can even do text search via this API. And the API I can call in one of 2 ways. I can either do it in JSON if I really want to do it in JSON, or I can do it using SQL. And behind the scenes, there's actually an Apache calcite interpreter. And that's been amazing for anyone in the community because I can add new SQL support very easily by using this calcite interpreter. That's how we ended up with joins being deployed as a supported term this year. New to Druid 18 is query laning. So with different configuration rules or by setting query properties at runtime, I can determine that a particular query should jump the queue and it should be executed ahead of other queries. So the broker's received my query request. What does it do? Well, armed with a Druid query, it then says, where is the data? And it consults a local cache in order to do that. We don't want to go and interrupt and send network traffic everywhere trying to find out where everything is. It does that on a local cache. And it issues then the query task to run on whichever server has that data. So option 1 is it's coming in now. It is live data. So it executes those queries on the middle manager as the results go back into the broker. But that is all in memory and it's row oriented. And we just blisteringly fast, but short-term memory, if you like. The second option is that it could be data that's been put onto the historicals, so that's already been optimized. And when the task starts running on these processes, it has the data on disk to start with, so it puts that into memory, and then we have a memory mapped caching area. So very frequently used data is likely already there. So when the query executes, it executes in parallel, in memory, across the cluster at lightning speed. And that's how we end up with Druid able to respond to queries in, well, I say under 400 milliseconds, but I've seen it much, much faster than that executing across these clusters. So when these results come back, there's a bit of post-calculation done at the broker, and then it's passed back into the requester. You can do subqueries, and you can also do join processes. So inside the memory of these processes, we can hold our master data. So when the query executes, it in memory will go and look at the master data and return that as a join back into the query. So another reason why these tasks run so quickly is because all of these task processes are discrete. There's no cross-node chatter. And because that data is immutable, there's no row locking, there's no recalculation, there's no redistribution of that data, there's no shuffle stage or anything like that. And that means we can take advantage of lots and lots of caching throughout the execution workflow of a query. If I want to scale up the number of people who can actually use this system, I can scale up the broker process. And typically you'd have 10 data servers to one query broker. That means I can handle more requests, I can improve my availability. Typically you're going to have, let's say, 2 brokers with some kind of ELB or a load balancer on top of those, just to give you high availability. Okay, all of these processes, the communications across the network are encrypted. So you get TLS encryption support for all of these processes. And of course, all of these different databases, the deep store, the metadata database, Zookeeper, all the local disks, you can use encryption so that it's encrypted at rest as well. One piece of advice I would give is that if you are starting to use Druid, play around with it to your heart's content on your laptop. But when you start to deploy it, make sure you have somewhere to put the metrics that get emitted. There's a special series of extensions where I can send metrics about what's happening in the queries, what's happening in the ingestion into some other service. So at Imply, we take the data into Kafka. There's a Kafka emitter. We actually then pick that up into another Druid application, and then we have built our own URI called Clarity that sits on the top. And I've seen people who are taking it directly into a Grafana stack, but whichever approach you take, please make sure you go and work out what those metrics mean. It's really essential. And finally, Druid was built from the ground up to be extensible. So the deep storage, the metadata databases, even individual types of incoming file format, all of it is extensible. So anybody can contribute different parts. So there's different extensions for R and for Python and Scala and Erlang, as I mentioned earlier. So it's meant to be an extensible platform. Okay, cool bit is how Druid actually treats the data as it comes in. So first of all, Druid will always partition by time first, and it creates these sequential episodes or intervals, or you'll see them called time chunks. And those contain further partitions, those partitions being called segments. I can then even sub-partition those as well into hashes and ranges if I use a batch, or I can, by default, if I'm using Kafka Kinesis, it's actually using the partitions in the underlying topic to sub-partition as well. And all of that is defined in a JSON document called the ingestion specification, that using that data loader interface, that console, you can now build using a really cool user interface. So that specifies the format. That could be JSON, awk, Avro, CSV, TSV, Parquet. I can't remember the others. And I also define what each of these periods of time is, whether that's a day or an hour, etc. And I can also say which dimensions I want to bring in from the underlying data, or I can let Druid just decide for itself what it is. Then I can apply these filters. So perhaps I only want to bring in data to do with Germany, or I only want to bring in data to do with France. I can do that here by applying a row filter, and I can also do transforms. So I have a little Raspberry Pi here with a sense hat on it. It brings all the data in centigrade. I've got a little transform that automatically puts it into Fahrenheit. That's a silly example, but you get the idea. I can do that in real time as the data is ingested. I can also do JavaScript functions for a load of these things as well. So now I've got these time chunks. What are the optimizations that Druid is actually going to perform to make this thing awesome? Well, it's going to learn the lessons of the past. It's not going to reinvent everything. It's going to pick up what we know is awesome about what we learned about the big data era, and it's going to use that to make things better. This is the real magic of what it's doing. It's going to translate this brilliant row-oriented format, great for writing data, into one that's awesome for OLAP, and it's so awesome it makes it sub-second responses to our queries. So the first thing is it's going to take this row by row representation, which is terrible when I've got a question about a particular column, and it's going to columnarize it. So now when I want the average satisfaction, I'm going to pick up just the satisfaction column, and I'm going to calculate the average satisfaction just on that column instead of doing a row scan. There's something I'd like to note here, and it's an important one of the things if you think about what should you do with Druid, and this is one of the things that we got from the time series database world. Notice that this, as you're seeing on the screen here, is a snapshot of between 12:30 and 12:55. That means that within Druid, because I've got it sharded by time, as soon as I want to know a question like, how does what happened in January compare to what happened in June? It does not have to do a huge table scan. It doesn't even have to do a huge column scan. It's going to pick up the satisfaction column for January and pick up the satisfaction column for June, and then execute that query in parallel. So great use cases for Druid are things like what happened in the last half an hour and how does that compare to what happened this time 2 weeks ago? Or how does the failure rate on this particular panel that I have in a field in Australia compare to the failure rate at the same time the previous year? Druid can answer those queries in parallel extremely quickly. I might be showing my age with this slide, guys. I do apologize. This is shorthand. I don't know if you guys, but imagine I'm trying to keep up with my boss who talks a lot very, very quickly in meetings, kind of like I'm doing. Instead of writing each word down, what I'm going to do is I'm going to write each word down using a codex. So when I need to read this back again, I don't read words and words and words. I just look at the codex. I look at the representation. So I end up not only with a performance boost because it's much quicker to read, but it's also much, much smaller to store. And that turns into much lower scan times of the data overall. And that's exactly what Druid does to our string columns in our example here. So instead of storing Peter, Paul, and Ahmed at a row by row level inside each column, I'm going to replace that with a dictionary of contents. It's actually an integer dictionary, and that lets us shrink the data size in Druid massively, but I can still get to the actual data. So I can still do things like top N and group by using the original values. Druid also does indexing based on coverage. So it's going to create a bitmap index. So this is fantastic when I want to do and or not or whatever binary operations on the data very clearly for things like filtering and for sorting. This actually is a compressed, and I can use roaring or concise bitmaps to build these indexes. The upshot of both of these things is that when Druid needs to do a group by or it needs to do a filter and it uses these encoded versions, it translates into massive performance improvements on the underlying data. A note, if you do start to use with Druid, choose wisely between representing the data in the schema as a number and representing it as a string. So for example, if you are importing application IDs into a Druid schema, application IDs might look like a number to you or me, but you have to ask yourself, how does Druid represent that? So if someone's going to filter a lot on application ID and they're never going to add two application IDs together, i.e. use them as numbers, store them as strings, and you can then therefore take advantage of this indexing feature within the Druid database. So now we've dimensions that let us do the filtering, they let us do the sorting, they let us carry out statistical functions, we can do aggregations, top ends, group bys, we can even do bucketing. All of that, as you can see here, that's the representation inside Druid. But imagine that our users are perfectly happy with 10-minute summaries of what happened, of the stock data or of the satisfaction levels, and that they don't want to ever filter by the individual customer's name. Perhaps there's your GDPR compliance thing there, but instead what we want is an indication of how many people there were that visited the site during that period. So what I use the roll-up functionality inside Druid, and it lets me reduce the granularity of my data when I ingest it using Druid's inbuilt roll-up feature, and we can create these windowed aggregates for those periods of time. So watch the when column as we switch to the next slide. And you can see that I've applied that granularity. It's now set to 10 minutes, and I've massively reduced the cardinality of that column. So if you think of yourself as being in a network analytics team, or someone who's dealing with telecommunications data, for example, millions and millions of events per second, I've suddenly massively reduced the complexity of storing those individual timestamps. So we then say to Druid, step 2, create 2 aggregations for me, please. I'm going to get rid of the stock change and satisfaction columns. I'm not going to store those anymore. I want you to create 2 columns. One's the sum of stock and one's the max of satisfaction. And there's a few different functions you can use there. They're all available in the Druid docs. Go and have a little look. And step 3, remember that we're not going to filter by who it was. We just want an approximate count. So we're going to take advantage of a Yahoo library. It's a data sketch library. It's a hyperloglog library. And excuse me, we're going to consolidate those individual who records into this hash. And I can still do a count distinct, but notice the reduction in the size of the actual storage of that column. It's worth noting that Druid is storing the metrics that I've generated separately from the data that it's going to use for filtering and for sorting, and adds just another layer of performance to the underlying database. Now I'm using hyperloglog here, which is for distinct counts, but there's also theta sketches for set operations. So if I wanted to work out who visited at 12:50 but didn't visit at 12:30, I could use a theta sketch. There's also quantile sketch as well. And that QR code at the bottom right corner is a fantastic video that explains that in extreme detail. That if you're interested in data sketches, go and have a look at those. So, okay, cool. Look at that reduction in size. So Druid rollup has shrunk my data massively, and that retranslates into huge reduction in scan time. Just one of the reasons why you get these sub-second query responses. And that's apart from the columnarization and sharding that lets me execute those queries and do time comparisons really quickly. And this dictionary encoding is bitmap indexing to speed up the filtering and the sorting. So I've seen people get a 1 to 100 compression ratio through this process. These global internet backbones who are storing petabytes of raw network data in Druid and retaining this real-time on-demand statistics without it costing them the planet to do it. So the result of that engine is that in many cases, the speed with which you can get queries back from Druid means I can do exactly what Tim Tully said. I can get all of my analytics from Druid in under a second instead of pre-calculating everything. Now, just a personal note here is a big mistake that I made when I started working with Druid nearly 2 years ago, is I thought Druid was just a very fast data warehouse, and it's not. Time is essential to your understanding of Druid. It's a flow of data as a flow of time. Time is central to the way that ingestion works. It's essential to the way that the data is optimized, to the way the data is distributed. So it's not just a columnar database. It's not just a faster OLAP cube or a very quick query engine. It is a time-sharded, columnarized OLAP data store that's suited to on-demand real-time statistical calculations. And because of the ingestion capability, you can do that on very fast arriving data, even if it's massive. Now, all of that wonderful functionality means you have to be careful and you need to be iterative to get this perfect ingestion specification, this wonderful cluster. And that's why the community is here. That's why I'm here today. If you want to go and have a look at Druid, please go and have a look at the Apache.org website. There is a distribution available there. You can download our distribution from Imply. There's Druid community pages that tell you about the local meetups that are happening in the area, the different meetup organizations. There's a Google Groups Druid user forum, and there is also an ASF Slack channel you can go and join. That will give you the nitty gritty of the kind of things people are actually using it for and the problems they get into as well. There is at Druid.io Twitter feed, and also add the skill to the Druid group on LinkedIn. And that's me. Time for questions.
Whoa, that was fantastic. Thank you.
Good. You're welcome.
Yeah, so now time for questions. Please use the raise the hand button. Then we will unmute you and you can ask Peter questions. Don't be so shine.
Yes. I don't bite.
I think everything was too clear for questions.
Okay, we have the first one. Vladimir.
Hi guys, I have a question about the management aspects of Druid itself. I come from a relational context. I've been a DBA myself, and what I wondered about backups, replication, all those fun stuff that you have to account for. How is that done in Druid?
Oh, you asking me? Yeah, you asking me a question about the real world here now, are you?
Yes. Thank you.